IIT series, question number 49. Consider the LCR circuit shown in figure. Find the net current I and the phase of I. Show that I equal to V upon Z. Find the impedance Z for the circuit. Here diagram is shown. This is capacitance. This is inductance. This is resistance. Here current I is divided into two parts. This is I1 and I2. So we write I equal to I1 plus I2. Now, if we consider the circuit starting from this voltage source and this external path we consider where resistance R is there. So we get R times I1 equal to V0 sine omega t, which will give I1 equal to V0 sine omega t divided by R. Suppose this is equation number 1. Now, let charge Q is flowing through the capacitance at time t. Then for this circuit, for circuit containing C and L, we write Q upon C plus L, current flowing through this circuit is I2. So L di2 by dt equal to voltage source, that is V0 sine omega t. Now we know that I equal to dq by dt. So we can write this relation as Q upon C plus L times d2q divided by dt2 equal to V0 sine omega t. Here we have assumed that charge Q is flowing through the capacitance. Now we consider the solution of equation number 2. So for that, I'm just erasing these portions. So let the solution of this equation is of the form Q equal to Q0 sine omega t. So dq by dt will give Q0 omega cos omega t, and second derivative d2q by dt2 will be equal to minus Q0 omega square sine omega t. So we put these two values, value of q and value of d2q by dt2 in equation number 2. So we get Q0 sine omega t divided by C minus Q0 times L omega square times sine omega t equal to V0 sine omega t. Now we can write it Q0 upon C minus Q0 L omega square equal to V0 Here we have divided the whole equation by sine omega t. So we can take common q0 from here. So q0 1 upon c minus L omega square equal to V0, which will give Q0 equal to V0 divided by 1 upon L, sorry, 1 upon C minus L omega square. So we have got the value of Q0. Now further, so we know that I2 is equal to dq by dt. So d upon dt of q we have assumed as q0 sine omega t. So, and we have got the value of q0 as v0 divided by 1 upon c minus l omega square. So we can write it d upon dt of sine omega t multiplied by value of q0. So this will give I2 equals V0, this value I will replace. So V0 cos omega t times omega divided by 1 upon c minus L omega square. So we can write it as V0 cos omega t divided by 1 upon omega c minus L omega. It's obvious this omega is taken in denominator. So we have got this equation. Now further, I1 equal to V0 divided by R sine omega t, and I2 equal to V0 cos omega t divided by 1 upon omega c minus L omega. So here, this is sine omega t, this is cos omega t. It means the two currents differ by pi by 2. Means phase difference is that of pi by 2. So here, phase difference is that of pi by 2. Now further, we find total current. So I'm deleting the diagram. So I1 plus I2, we put the values. So V0 upon R sine omega t plus V0 upon 1 upon omega c minus L omega times cos omega t. Here we make certain assumptions. So let V0 upon R equal to C cos phi and V0 divided by 1 upon omega c minus L omega equal to C sine phi. Now, if we square these two and add, we get C square equal to V0 square divided by R square plus V0 square divided by 1 upon omega C minus L omega whole square, which will give C equal to square root of this all term. So here, from here, V0 can be taken common, then 1 upon R square and plus 1 upon 1 upon omega C minus L omega whole square. From here, from these two, V0 upon R equal to C cos phi and V0 upon root of, sorry, V0 upon 1 upon omega C minus L omega equal to C sin phi, we can get tan phi. So we divide this by this. Or so let's write it further. So we get tan phi equal to tan phi, this will remain in numerator. So we will get R divided by 1 upon omega C minus omega L, which will give phi equal to tan inverse R divided by 1 upon omega C minus omega L. Now, so we put these values as we have assumed. So from here, V0 upon R is taken as C cos phi. So this term I1 plus I2 will become C cos phi sine omega t plus C sine phi cos omega t. And this can be written as C times sine omega t plus phi, because we know the formula sine A plus B equal to sine A cos B plus cos A sine B. So we have got total current I1 plus I2 as C sine omega t plus phi. Now, so I equal to I1 plus I2, which is equal to value of C we have obtained as V0 this much. So we can write it here. V0 times root of 1 upon R square plus 1 upon omega C minus L omega square and here sine omega t plus phi. So we have got the value of I. So we divide this I by V0. So I divided by V0 will be 1 upon Z, which will be impedance, which will be equal to root of root of 1 upon r square plus 1 upon 1 upon omega c minus omega L whole square. We can put bracket here also. Okay, so where Z is impedance. Thank you.